Welcome back to TMac FPV, your home for your journey to better FPV, fun flights and racing stuff. I'm TMac. Today we're going to build out one of the, if not the, most versatile Micro FPV 3-inch quadcopter freestyle frames, the FlexRC Colugo. Let's do this! Alright, these are the components that we'll be using in our FlexRC Colugo build. The build comes in with a total dry weight of approximately 150 grams and with an RDQ4S 650 milliamp LiPo of 84 grams. The total all-up weight is 234 grams. Keep in mind we're building a freestyle, more of a slow, smooth flying cinematic quadcopter as opposed to a racing drone. In fact, that's the reason we went with the Airblade Superman 1404-3850 motors, which are known more for their efficiency than they are for their thrust. The thrust to weight ratio of this complete build is about 5.3, and compared with one of our more recent racing drone builds, that thrust to weight ratio was, I think, 11.1. So obviously there's a dramatic difference in the thrust to weight ratios based upon the type of quadcopter you're building for a specific type of flying. The FlexRC Colugo frame without the TPU parts comes in at 38 grams. You can get the TPU, antenna, and camera mounts separately, and those combined come in at 3 grams. Before I go any further, the FlexRC Colugo frame is one of over 30 different 3-inch frames from over 20 different manufacturers in our Micro FPV 3-inch frames guide, which you can download through a link for free in the video description below. In that frames guide, it compares the different parameters of the frame, such as the wheelbase, how much the frame weighs in grams, the frame weight, what types of motors the frames support, whether they're 11XX, 13XX, all the way up to 16XX. In fact, some frames are versatile enough to support from 11XX to 16XX motors mounting, and we've got that parameter listed in our frames guide. We've also got the max stack height for each of the frames, as well as the base plate, arm, side plate, and top plate thicknesses. We also show the parameter of what type of stack mount pattern is supported, whether they're the 16 by 16 or the 20 by 20 stack mounting patterns, and once again, some frames support both of those. We even have some frames that support dual stacks, such as this FlexRC Colugo frame, whereas other frames are only single stacks. In addition, we show what types of camera mounts are supported by each of the frames, whether they're the 14 by 14 nano size camera mounts or the 19 by 19 micro size, or perhaps even the standard size camera mounts. And once again, some frames are versatile enough where they support all 3 different kinds. Of course, we also list the price of each of the frames in this Micro FPV 3-inch frames guide. So it's a good reference document to download and print out for your reference when considering which frame you want to choose for your Micro FPV 3-inch build. We've got a similar document for your Micro FPV motors. We've got the Micro FPV motors chart, which you can download through a link in the video description below. And that contains over 45 different motors from a boatload of manufacturers. And in that motors guide, we compare various parameters as well. The number of cells of the LiPo that's supported, a bunch of different parameters. One of the key components, or the key parameters that we do list in that motors guide, is the thrust to weight ratio. So if you're comparing 2 different micro motors that are able to support the same number of cell LiPos and they're approximately the same cost, you might want to look at the thrust to weight ratio to figure out which one's going to give you the best performance. In this build, we're going to be using the Mamba Mini Mark II flight controller and ESC, and for the first time ever, we'll be using the caddx tarsier 4K camera, and we'll be doing a video in the near future with more specifics on the caddx tarsier here coming up shortly. The way we're going to do this build is through a series of pictorials. As a matter of fact, in addition to this video, we've put together a pictorial build PDF document, which you can download through a link for free in the video description below and print out and use as a reference for your future Micro FPV build. In addition to the build itself, we'll be going over quickly the BetaFlight setup of the build and we'll conclude with a short flight showing both the videos of the FPV feed as well as the 4K HD video from the Tarsier camera. We'll also be including this video in our Micro FPV 3-inch quad build playlist, which should pop up in the upper right hand corner of this screen for your convenience. All right, let's get started with the build. Now we're going to get into the BetaFlight setup of our FlexRC Colugo, and the first thing I like to do before I flash new firmware to the flight controller is I like to go to our command line interface, or the CLI, and type the word dump into our CLI and hit return, and that's going to give us the current configuration of our flight controller before we make any changes to it. With that, we copy and paste the text that is displayed on the screen from our CLI dump into a text file onto our computer, that somewhere where we can access it later. That way, if for any reason we mess something up with our configuration, we can always revert back to the original configuration of our flight controller before we make any changes, just by taking that text, copying and pasting it back into the CLI, hitting return, and then typing save into the CLI and hitting return. And by doing so, that will revert the flight controller back to its original configuration prior to you making any changes to it. Next, we're just going to update the firmware on the flight controller with the latest version. This is not a necessary step. You can actually use previous versions of firmware. However, they may not have the latest features. So in this case, I just decided to use the latest firmware for our Colugo build, which is 4.0.4, I believe. So we're going to use our Fury F4 OSD board that we took note of earlier from our CLI dump, and we're going to choose the latest firmware, load the firmware online, and then go ahead and flash the firmware to the flight controller. Next, we're just going to go through the various tabs on BetaFlight really quickly. We go to Setup tab first, take a look at the model, click our quadcopter's level on a flat surface, click Calibrate Accelerometer, and you see the model move and the accelerometer is calibrated. Go to our Ports tab. These things that we're looking at now have already been set up. I'm just giving you an overview of what changes we've made. In our Ports tab, we've got Serial RX on UART1, and we've got Smart Audio enabled on UART3. Under Configuration, I've decided to reverse the props direction And the reason I do that is to keep debris from being thrown into the camera lens, and also supposedly it does help in some ways when you fly into trees or branches. The props are spinning out away from the quadcopter, and therefore it's not actually grabbing the branches when you fly into the trees, should you happen to do so, which I tend to do quite often. We've got D-Shot 600. I always set my arming up to 180 degrees, which means that I can arm the quad no matter what angle it's at. Once again, this is so that if I get stuck at the top of a tree, I'm able to arm the quad and try and use pitch, roll, and throttle to wiggle it out of the top of the tree, and perhaps it'll fall back down to ground, and I can save my quad from there. I've got the gyro and the PID loop frequency set to 8K, 8K. I've got my receiver set to serial-based receiver, S-bus, air mode on, anti-gravity on, dynamic filter on. I've got my beaker tone set to 3, which I do all the time because that's the tone I like. You can actually change these to different tones, and you can figure out which ones you like. I like 3. And I've got it set to RX set, beeps when the aux channel is set for beep. It's just as a backup for my beeper. Everything else is here. Save and reboot. Go to power and battery. These are the values I use for my power and battery. Fail safe, I always set to drop. PID tuning. These are the PIDs I have set up for this particular quadcopter. I've got 3 different rate profiles. I always use the same 3 rate profiles. You can think of these as speeds, if you will, or gears. I always keep my RC rates at 1, and what I change is the super rates, which changes your max velocity in degrees per second. So this is my slow speed, or what you might consider your race rates. Profile 2, these are increased just by increasing the super rate. And profile 3, these are used for more of freestyle. And I've got my super rate set at the highest rates out of those 3 for max velocity in degrees per second of 909. More importantly, perhaps, are the filter settings. The default filter settings on BetaFlight are set up for 5-inch quadcopters, so I went ahead and did make these changes. I'm not sure exactly what the default settings are for these 2 down here. I think they might be 150. I always change them to 100 for my micros just because I know that that works, and I'm okay with setting it at 100 instead of 150. This value here, I believe, is 450 by default or somewhere around that. I set this up to 800 initially for my micro 3 inches, but we can take a look at a parameter in the OSD settings that you can look at post-flight to figure out what a better value might be for this. But it's definitely going to be higher for your micros than it is for 5-inch quads. So you'll want to change this for micro FPV quads as opposed to 5-inch quads. Receiver tab, I've always got my channel mapped to AETR 1234, and I've got the RSSI set up to aux 8, which is channel 12. Modes, I set up my mode. I've got an arm switch set up on aux 1. I've got angle and acro trainer set up on a switch, and when they're not in angle or acro trainer mode, the little yellow blip is over here, which means it's in acro mode. And I fly almost 100% of the time in acro mode unless I'm specifically doing something, testing the quad out for some reason, either in acro trainer or angle mode. Beeper I've got set up on aux 3. This Mamba flight stack does have a flash black box capability, so I've got that set up. Got flip over after crash or turtle mode set up, and launch control set up. Adjustments, as I mentioned, I've got 3 different rates. So under adjustments, I've got our rate profile selections for 1, 2, and 3, which we just went over in modes under slot 1 and aux 5. And then I've got 3 different OSD profile selections set up, and I put those under slot 2 and aux 6. Motors, when you set the quad up, you just need to check to make sure that your motor direction's spinning properly. Let's get to OSD. As I mentioned, I've got 3 different OSD profiles. Primarily, I use the first 2. The first one is what I normally use for all of my flights, but OSD profile 2, I've got the stick displays set up, and I use that primarily for learning new maneuvers, and I can go back and take a look at the DVR and see what my actual stick movements were doing in relationship to what I planned on having them do. Therefore, I can make corrections just by going back and looking at the DVR and enhancing my flight skills in that manner. But you can set up with BetaFlight 4.0 and above, I believe, 3 different OSD displays. You can move these around just by clicking and dragging the various options. The parameter I mentioned earlier about setting up to figure out what that frequency number should be in the filters settings of the PID tuning tab is max FFT. Click this on for your post-flight statistics, and that will provide you with a number after your flight is over as to the maximum fast Fourier transform frequency, peak FFT frequency. And if you add 20 to 25 to that number in your post-flight statistics, that will give you the resultant number that you want to use for this setting here. All right, that's going to do it for our BetaFlight setup. Let's get to our flight. If you liked the video and found it useful, make sure to give it a thumbs up below. Share it with your friends. Make sure to grab your free frames guide, micromotors chart, and build pictorial document from the links in the video description below. Thank you for your time. We'll see you in the next video. Clear skies, my friend.